While Europeans were still throwing their waste into streets and dying from diseases that could be prevented with basic hygiene, Native Americans were performing brain surgery with success rates that wouldn't be matched in Europe for another 1,000 years. The technological gap between Native American civilizations and European societies wasn't just significant. It was so vast that calling it primitive versus advanced doesn't begin to capture the reality. We're talking about civilizations that had mastered engineering, education by examining the actual technological capabilities of Native American civilizations compared to their European contemporaries. While medieval Europeans were living in their own filth and believing that bathing caused disease, Native Americans had developed urban planning, sewage systems, and public health measures that created cities cleaner and more advanced than anything Europe would see for centuries. The year 1000 CE provides a perfect comparison point that exposes just how backwards European technology was compared to Native American innovations. While Europeans were struggling with basic metallurgy and hadn't figured out how to build structures that wouldn't collapse in earthquakes, Native Americans were creating architectural marvels that modern engineers study for inspiration and construction techniques that remain superior to many modern methods. Surgical technology among Native Americans reached levels of sophistication that would make modern medical schools envious. Archaeological evidence from Peru shows successful trepanation surgeries, drilling holes in human skulls to relieve pressure or remove damaged tissue, with survival rates exceeding 80%. These weren't desperate procedures attempted by desperate people. They were routine medical interventions performed with precision tools, anesthetic compounds, and surgical techniques that European doctors wouldn't master until the 19th century. The surgical instruments used by Native American doctors were crafted from obsidian, creating blades sharper than modern steel scalpels. Volcanic glass can be knapped to create edges only a few molecules thick, producing cutting implements that slice through tissue with minimal trauma and faster healing times than metal instruments. European surgeons were still using crude iron tools that caused massive tissue damage and frequently led to fatal infections. But the real technological superiority shows in their anesthetic knowledge. While European surgeons operated on fully conscious patients who often died from shock and pain, Native American medical practitioners had developed sophisticated anesthetic compounds from local plants. They understood dosage calculations, patient monitoring, and pain management techniques that kept patients unconscious during major procedures and comfortable during recovery periods. Cocaine, derived from coca leaves, was being used as a local anesthetic in South American surgical procedures more than 1,500 years ago. Native American doctors understood the precise dosages needed for different types of procedures, how to combine anesthetic compounds for maximum effectiveness, and how to manage side effects that European medicine wouldn't encounter until cocaine was discovered by European chemists in the 1800s. Pharmaceutical development represents another area where Native American technology was centuries ahead of European medicine. While European doctors were still bleeding patients and prescribing mercury for everything, Native American healers had identified and developed hundreds of effective medicines from plant compounds. Modern pharmaceutical companies are still studying Native American medicinal knowledge and attempting to synthesize compounds that were being used therapeutically for thousands of years. Aspirin, one of the world's most widely used medications, was originally developed by Native Americans who extracted salicylic acid from willow bark and understood its anti-inflammatory and pain-relieving properties. They had also developed complex preparation methods that maximized therapeutic effectiveness while minimizing side effects, knowledge that European medicine didn't acquire until the late 19th century, when German chemists finally synthesized acetyl salicylic acid. Digitalis, used to treat heart conditions, came from Native American knowledge of foxglove plants and their cardiac effects. Quinine, the anti-malarial drug that allowed European colonization of tropical regions, was extracted from cinchona bark by South American indigenous peoples who understood its medicinal properties centuries before Europeans encountered malaria in the New World. Agricultural technology developed by Native Americans created food production systems so advanced that modern sustainable agriculture is still trying to replicate their methods. The Three Sisters planting technique, corn, beans, and squash grown together, represents an understanding of soil chemistry, plant biology, and ecological relationships that European farmers wouldn't develop for hundreds of years. This wasn't accidental companion planting. It was sophisticated agricultural science. The corn provides structures, cultural support for the beans, while the beans fix nitrogen in the soil that feeds the corn and squash. The squash leaves create ground cover that retains moisture and prevents weeds, while its thorny stems protect the other plants from pests. This system actually improves soil quality over time while maximizing crop yields, creating sustainable food production that could continue indefinitely. European agricultural methods of the same period were destroying farmland through soil depletion, crop failures, and erosion. Native American agricultural technology created food security that supported populations European methods couldn't sustain. The genetic engineering achievements alone put Native American agriculture centuries ahead of European development. Modern corn was created from a wild grass called teosinte through thousands of years of selective breeding by Native American agriculturalists. This transformation represents one of the greatest genetic engineering achievements in human history, taking a plant with tiny seeds and creating massive ears of kernels through careful selection and breeding techniques. The genetic changes required to accomplish this transformation demonstrate understanding of plant genetics that European farmers couldn't match. Potatoes, now a staple food worldwide, were developed by Andean peoples who created hundreds of varieties adapted to different altitudes, soil conditions, and climate zones. They understood principles of crop rotation, soil management, and plant breeding that allowed them to feed large populations at altitudes where European crops couldn't survive. The agricultural technology required to create sustainable farming systems in the Andes remains impressive by modern standards. Metallurgical technology among Native Americans included techniques that European metalworkers hadn't developed. The precision casting, alloying, and finishing techniques used by civilizations like the Moche created artifacts that European smiths couldn't duplicate. They understood temperature control, alloy composition, and metalworking techniques that produced superior results to European methods of the same period. Bronze working in the Americas reached levels of sophistication that impressed European observers when they finally encountered it. Native American metallurgists could create complex alloys, achieve decorative effects, and produce tools with superior performance characteristics. Some techniques used by Native American metalworkers weren't rediscovered by European craftsmen until the Industrial Revolution. The lost wax casting technique used by Native American artists allowed them to create incredibly detailed metal sculptures and tools with precision that European metalworkers couldn't achieve. This process requires understanding of thermal expansion, mold making, and metal flow characteristics that represent advanced materials science knowledge. Engineering achievements across the Americas demonstrate technological capabilities that modern engineers struggle to replicate. The earthquake-resistant construction methods used by Andean civilizations created buildings that have survived seismic events that would destroy modern structures. The precision of Inca stonework creates joints so tight that you can't insert a knife blade between stones, achieved without metal tools or mortar. This construction technology required understanding of materials, science, structural engineering, and seismic design principles that weren't developed in Europe until the modern era. The techniques used to quarry, transport, and position massive stone blocks remain impressive by contemporary standards. Some stones in Inca constructions weigh over 100 tons and were fitted with precision that modern construction equipment struggles to match. Hydraulic engineering by Native Americans created water management systems that sustained large populations in challenging environments. The irrigation systems built by civilizations in the American Southwest moved water across desert landscapes with efficiency that modern irrigation systems struggle to match. These weren't simple channels. They were sophisticated water management networks with flow controls, distribution systems, and maintenance protocols. The raised field systems created by Maya and other Mesoamerican civilizations transformed wetlands into productive agricultural areas while managing water levels for optimal crop production. These systems required understanding of hydrology, soil science, and ecological relationships that allowed sustainable agriculture in environments that European technology couldn't utilize effectively. Road building technology developed by Native Americans created transportation networks that exceeded European infrastructure in both scope and quality. The Inca road system covered over 25,000 miles of challenging terrain, with engineering solutions that modern highway departments find impressive. These roads included bridges, tunnels, rest stations, and communication systems that allowed efficient transportation across mountains, deserts, and jungles. The engineering challenges overcome by Inca road builders required understanding of geology, structural engineering, and construction techniques that European road builders hadn't developed. They carved roads through solid rock, built suspension bridges that spanned massive gorges, and created highways that maintained consistent grades across terrain that modern engineers consider nearly impossible to navigate. Astronomical technology among Native Americans created observational capabilities and calculation systems that were more accurate than European astronomy of the same period. Maya astronomers could predict eclipses, track planetary movements, and maintain calendars that remained accurate for thousands of years. Their observational methods and mathematical techniques were more sophisticated than European astronomy until the telescope was invented. The astronomical knowledge required to create accurate calendar systems demonstrates understanding of celestial mechanics, mathematical principles, and observational techniques that European astronomers were still developing. Maya calendar calculations were more precise than the Julian calendar used in medieval Europe, and didn't require the corrections that European calendars needed to remain accurate. The Dresden Codex contains astronomical calculations that demonstrate understanding of mathematical concepts like zero, place notation, and complex arithmetic that wouldn't appear in European mathematics for centuries. Maya mathematicians were working with base 20 numerical systems that were actually more efficient than European mathematical methods for many calculations. Textile technology developed by Native Americans created fabrics and weaving techniques that surpassed European textile production in both quality and complexity. The engineering required to create textiles found in Peruvian archaeological sites required understanding of fiber properties, dye chemistry, and weaving techniques that European textile workers hadn't developed. Peruvian textiles from 2,000 years ago show weaving complexity with thread counts and pattern sophistication that European textile production wouldn't match until the Industrial Revolution. The chemical knowledge required to create permanent dyes, the engineering needed to build complex looms, and the mathematical understanding necessary for intricate patterns all demonstrate technological capabilities beyond European textile production. Some Native American textile techniques are still considered trade secrets that modern manufacturers struggle to replicate. The precision and durability of ancient Peruvian textiles exceed many modern synthetic materials, demonstrating technological knowledge that hasn't been fully recovered, despite modern scientific analysis. Urban planning technology among Native Americans created cities with infrastructure that European urban centers wouldn't match for centuries. Cahokia, located in present-day Illinois, featured sophisticated urban planning with residential areas, commercial districts, ceremonial centers, and infrastructure systems that supported over 20,000 residents, larger than most European cities of the same period. The urban planning required to create sustainable cities in diverse environments demonstrates understanding of civil engineering, public health, and social organization that European city planners were still developing. Native American cities featured sewage systems, water supplies, and waste management that created healthier living conditions than European urban centers. Teotihuacan, near modern Mexico City, was planned as a grid system with sophisticated drainage, apartment complexes, and public spaces that wouldn't look out of place in modern urban development. The engineering required to create this urban infrastructure demonstrates technological capabilities that European cities wouldn't achieve until much later periods. Communication technology developed by Native Americans included systems that could transmit information across vast distances with efficiency that European communication networks couldn't match. The Quipiu system used by Inca administrators recorded complex information using knotted cords that functioned as both numerical records and narrative accounts. This information storage technology allowed Inca administrators to maintain records of population, resources, and administrative information across their empire without written language. The sophistication of Quipiu record-keeping demonstrates understanding of information theory and data management that European administrative systems were still developing. Signal systems using smoke, mirrors, and other methods allowed Native Americans to communicate across hundreds of miles with speed that European communication networks couldn't match. These weren't primitive signaling methods. They were sophisticated communication technologies that could transmit complex information quickly across vast distances. Weapon technology among Native Americans included innovations that were often superior to European military equipment of the same period. The atlatl, or spear thrower, could propel projectiles with greater force and accuracy than European weapons. Composite bows created by Plains Indians generated more power than European archery equipment, while being lighter and more durable. The materials science knowledge required to create these weapons demonstrates understanding of leverage, trajectory, and materials properties that European weapon makers were still developing. Native American weapons were often more effective in their intended environments than European alternatives, representing technological solutions specifically adapted to local conditions and combat requirements. Chemical technology among Native Americans included processes for creating materials and compounds that European technology couldn't produce. The rubber processing techniques developed by Mesoamerican civilizations created waterproof materials, elastic compounds, and manufactured goods that European technology wouldn't duplicate for centuries. The chemical knowledge required to process latex into rubber products demonstrates understanding of polymerization, chemical modification, and materials science that European chemistry hadn't developed. Native Americans were creating rubber balls, waterproof containers, and elastic materials thousands of years before European chemists understood the processes involved. Mining and processing technology used by Native Americans extracted and refined materials with efficiency that European mining couldn't match. The silver mining operations in the Andes processed massive quantities of ore, using techniques that European miners admired and adopted. Native American miners understood geology, ore processing, and extraction methods that were more advanced than European mining technology. The precision tools, extraction methods, and processing techniques used by Native American miners demonstrate technological knowledge that European mining operations were still developing. Some Native American mining sites show evidence of operations that continued for centuries, indicating sustainable extraction methods that European mining typically couldn't achieve. Environmental engineering represents yet another area where Native American technology exceeded European capabilities. The controlled burning practices used across North America created managed landscapes that maximize biodiversity while providing optimal conditions for hunting and gathering. This wasn't accidental forest management. It was sophisticated ecosystem engineering that required understanding of plant ecology, fire behavior, and animal habitat requirements. These landscape modification techniques created the pristine wilderness that Europeans encountered, which was actually carefully managed parkland maintained through centuries of environmental engineering. Native Americans understood ecological relationships and environmental management principles that European land use practices were destroying through deforestation, overgrazing, and unsustainable agricultural methods. By now, you should be questioning everything you were taught about technological progress and cultural advancement. The evidence is overwhelming that Native American civilizations had developed technologies that were centuries ahead of European capabilities in virtually every field of human endeavor. This wasn't primitive technology. It was advanced science and engineering that European civilization was still struggling to achieve. The technological gap between Native American and European civilizations at contact wasn't narrow. It was a chasm that demonstrates just how advanced Indigenous American civilizations had become. While Europeans were still figuring out basic sanitation and struggling with metallurgy, Native Americans were performing brain surgery, building earthquake-resistant architecture, and creating agricultural systems that modern sustainable farming is still trying to replicate. The systematic destruction and dismissal of Native American technological achievements represents one of history's greatest intellectual tragedies. Technologies that could have advanced human civilization by centuries were destroyed, dismissed, or stolen without acknowledgement. The scientific revolution that Europeans claim credit for was largely built on knowledge acquired from Native American innovations that were then rebranded as European discoveries. The next time someone talks about European technological superiority or primitive Native American surgeries, remember that the evidence shows exactly the opposite. Native Americans were the technological innovators, the scientific pioneers, and the engineering masters whose achievements laid the foundation for modern technological development. European civilization didn't bring technology to primitive peoples. It encountered advanced civilizations whose technological achievements it couldn't match, understand, or properly acknowledge.